Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a challenge related to that topic, and then solve it live on stream. This week it's programming idiot-proof APIs. And what do I mean by that? Well, we'll see in just a moment. If you'd like to follow along with today's code, you can check it out on github.com/jamesshore/livestream. Check out this tag right here, 2020-07-28. As always, your comments and questions are welcome. John CVV, welcome. Thanks for coming. And just go ahead and toss them in the chat, just like John did here. And I will take some as we go, and also have some time at the end for more comments and questions if there are any. All right, so let's talk about idiot-proof APIs. So what do we mean by idiot-proof APIs? What I mean is writing your APIs, writing your software programming interfaces so that they are hard to use incorrectly. So let's be a little more specific. Let's say that we are programmers and we have a task to write a little logging utility. And one of the tasks required for writing this logging utility is we need to write out the current date and time. And we have to do it in a very specific format, this format right here. Now, we know that there's a clock module available to us that will write the current time out in a particular format, but we don't know anything about it. This is the part where we're printing. Now, we actually built this module last week, and if you'd like to see that, jamesshore.com/s/LNL. I've got this new short link for you. That's LNL, like lunch and learn. So yeah, jamesshore.com/s/LNL will take you to all the back episodes. In particular, last week's episode, which was called International Dates and Times, is where we built this clock module. But for today's episode, let's assume that we don't know anything about this module. We're a programmer. We have to write this logging utility. We need to write out the current date and time. We know there's a clock module, but we don't know anything about how it works. So how are we going to actually program this code? Well, let's go see. Got the code here. Again, if you'd like to follow along, it's github.com/jamesshore/livestream. Check out the tag 2020-07-28. And then you will need node.js installed because all the code is written in node.js. But after that, you can, everything's vendored in, so you can build the code by doing /build.sh, and that will lint and test the code. And you can use build quick to only build and test the things that have changed, watch quick to lint and test files, things whenever any file changes, and run quick, or just run, to run the code. But we don't have any code just yet. And if you're on Windows, instead of using ./build.sh or whatever, just use build or watch or run. Okay, so that's the code. And what we have here is we've got our little example right here. There's nothing in it, but so we're the programmer. We need to write this little logging utility. We need to write out the current time. And we know that there's a clock available to us. And we're a conscientious programmer. So we're going to do this test-driven. And we know that we understand the nullable infrastructure wrapper pattern. And if that's new to you, you can check out the backlog again. That's jamesshore.com/s/LNL. Look for the episode titled Testing Without Mocks to learn all about infrastructure wrappers and the nullable infrastructure wrapper pattern. But let's say that we already understand that. So we're going to make ourselves a command line. And we'll make ourselves a clock. And we will run our code, pass in the command line and clock, and then we'll expect that something is going to happen. And let's see what we got available to us. Yeah, we'll say that the last standard out is, well, whatever that format needs to be. In our case, we're going to say that it's happening at the epoch, so it'll be January 1st, 1970, 1300 UTC. And we're choosing 1300 because that will force the 24-hour time. And the way that means that we will have to start the clock off at a specific spot, and that is going to be 4680000. So there's our test. Now we're going to run that test, and of course it's going to fail because I forgot a semicolon, as usual. And I'll need to do assert equal. And now we're saying that it expected null, but we got, or we expected this, but we got null. And that's because we're not writing anything out. So now we'll go into our production code, and we have to actually use this clock tool. First, let's write something out to the command line. So we'll say command line dot, and again, we'll check the help here. We'll say write standard out something with a line feed at the end, and let's assert that we have a line feed at the end here too. Okay, so we're using the command line correctly. That's good. Now we need to use the clock. So the time is going to equal clock dot what? So obviously, if you're a programmer using an API, you're going to be using this control space or whatever the format, whatever the shortcut is on your keyboard to look at the methods pretty frequently. We look through and we see two formatted string right here on the top. Well, that's great. And then that's going to take a format and a locale. Well, I don't know what either of those are. Locale makes sense, but the format I'm not so sure about. So I'm just going to not pass any of them in right now. And here I'll pass in the time, and we'll just see what comes out of that. So that's giving us January 1st, 1970. So we definitely are doing okay there, but it's the wrong format. So obviously we need to figure out what this format is. And at this point, we're going to sort of stall because we don't know what the format is, and we'll do some searching, and we'll thrash around. Eventually, we'll ask somebody, and they will tell us, "Oh, toFormatted string uses the international.datetime format options." And we say, "Okay, well, then we go look up the international.datetime format, and we learn that what we need is the medium date style, the long time style, and we need to tell it not to use 12-hour notation." And when we do that, and we pass it in, it almost works, except we didn't do the locale. So no problem, we'll just add that locale. This is the US English formatting. And there we go, test pass. Done, right? Everything looks good. So we run our tests, so we ship the code because the tests are passing, right? Everything's got to be fine. And it gets into production. And when it gets in production, it fails. It does not actually print out the right message. And why is that? Is it because we're idiots? Are we idiots and we use this API incorrectly? No, I don't think so. Is it because we're lazy? Well, we didn't go out and we didn't study the documentation, we didn't study the test, we didn't study the code. So in a sense, we were lazy. But honestly, no, we were just being an ordinary programmer trying to do our job. The API was poorly designed. In general, when things go wrong, you want to look at the system, not the people. Because people always make mistakes. And it's our job to design our systems, including our APIs, to prevent those mistakes, prevent them from happening. And never, ever, ever expect anybody to read the documentation because they're not going to. So when I say idiot-proof code, that's what I'm talking about. I'm writing code to help people use your APIs correctly because they're not really idiots. They're us. They're me. They're you. So that's the question for today. How can we write idiot-proof code? How can we make our code easy to use correctly, difficult to use it incorrectly? And the challenge for today is to improve the clock API that I just demonstrated and to make it difficult to use incorrectly. So how are we going to do that? I'm going to let you think about that for a moment. While you're thinking about that, I want to remind you that this show is made possible by the people who hire me for agile software development, training and coaching and consulting. This is a wonderful group of people who bring me in to help with anything from specific agile practice training like test-driven development all the way up to helping them design their software process or even how they're going to have multiple teams, large groups of teams work together. It's thanks to these fine people that I'm able to do this show for you today, because if I didn't have them hiring me and paying me to come out and work with them, or these days work remotely with them, I would not be able to do this for you. I'd have to get a real job. So if you'd like to join this group of people, go ahead and send me an email, jshore@jamesshore.com, or visit me online, jamesshore.com. I also welcome tweets from anybody at any time on Twitter. My Twitter handle is @jamesshore. I do tend to work with companies that are on the less bureaucratic side of things. So maybe 300 people in the engineering organization that you're working in at most. Typically, they're really looking. They have the culture to have a lot of business agility, but they don't have the technical capacity yet. So if that's you, again, I'd love to hear from you. jshore@jamesshore.com. Happy to set up a free consultation. All right, let's get back to today's challenge. We want to improve the clock API. We want to make it difficult to use it incorrectly. How do we do that? Well, there's a variety of techniques. They can all be used independently or together. The four I'm going to talk about today are these four right here. First, we can clarify our usage by improving our names. Second, we can provide inconvenient defaults rather than convenient defaults to make it so code doesn't pass by coincidence as it did for us just now. We can also just not provide defaults at all and use and require explicit code, which will make the code easier to understand in the future. And we can document the usage by failing fast. I'm going to go through each of these live with an example. So let's go ahead and see that now. So back in our code, here's our clock example. I'm going to go ahead and turn off this test so we can come back to it later. And in our infrastructure, we've got our clock code here, our test here, and our actual production code here. So this is the actual API that we're going to improve. And we're going to improve just one little piece of it, which is this toFormatted string right here. So again, four options here. We can use, first of them is that we can use our names to help people understand what's going on. Because remember, people are not going to read your documentation unless they absolutely have to. Unless things go wrong, they're not going to read your documentation. So you remember how when we started out writing the clock code and we said, what is this format? And we had to ask people and ask for help. We could have made that more clear by using better names. One option would have been to use a name like to international date time formatted string. That's one way to do it. Another way to do it would be to say, instead of format here, we could say international date time format options, like that. For the locale is optional, but that's not obvious looking at it. We could say optional locale. These are all different ways of using names to make your code easier to understand. It's not perfect, but it does provide enough of a hint that it will save time for some people. Now, of these two choices, saying to international datetime formatted string or international datetime format options, I have a slight preference for international datetime format options, just because I feel like to international datetime formatted string is a little less obvious and it's a little bit more verbose. By making the variable name here, it's not going to really affect anybody except ourselves. So I like that a little bit better. But honestly, the best way to improve your naming is to use some sort of collective code ownership. That's where multiple people on the team can all work in the same parts of the program. That way, as different people touch the code, they'll improve it. Other options are pair programming and mob programming. Those tend to lead to really good names because you have more people thinking about it, or at the very least, code reviews. Although I find that in code reviews, people are more reluctant to make substantial changes unless they see a bug or other problem. So anyway, for me, not having a pairing partner right now, I think this is a pretty good option. So let's go ahead and go with that. And this is interesting. I'm getting some test failures in my provides current timestamp test. It's saying that the actual is somehow, maybe I've got these backwards. Well, I'm not going to try to mess with that right now, but when we originally wrote this code, which was 2 episodes ago, it's called No More. The name of the episode was No More Flaky Clock-Based Tests. We specifically used is at least to try to prevent flaky tests, but looks like we're still getting them. I'm not sure why. I think what we can do here is we can use a different approach. We can set the expected value before the actual value. We can say if the actual value does not equal the expected value, we'll recreate the expected value. And that will fix it. And then we'll assert that the actual should equal the expected. Okay, hopefully that doesn't keep happening. Sorry about the digression. So that's our first option here is we're going to use better names to better document how our API works. Just a little thing, but it helps people understand the API, makes it less likely that they're going to use it incorrectly. Now, the second choice here is we can use inconvenient defaults. In our clock example here, the reason things went wrong is because by default, the create null clock uses UTC as its locale. But of course, my computer uses the Pacific time zone in the US. And so my test passed, but it failed in production. Now, you see similar things happen where maybe somebody's not writing the test, or if I had been in England, sometimes you get the situation where it works on your machine, but then the actual production machine is in a different time zone and it would fail there. So by using a inconvenient default, I make it more likely that I'll notice that the code is wrong. So for example, here, rather than using UTC for my time zone, I could have used something like Lord Howe Island near Australia. I chose Lord Howe Island because there's not a lot of people living there, and also it's a weird time zone. It's 10.5 hours off in the winter and 10 hours off on daylight savings, or something like that. So let's go ahead and change our default here from being UTC, which is going to be coincidentally correct far too often, and instead use Lord Howe Island. Now, of course, you can use whatever inconvenient default you want. We'll run this. This is going to cause our test to fail because now we're at 10 a.m. in UTC plus 10. So I'll just change this here. Default the time zone and locale to little used values to prevent false successes. Similarly, I have France set as my default locale for the language, but France there's a lot of people who speak French, and France is a big country. So let's choose a locale that's a little less likely to be used. And now, for my team right now, it's just me here in the US, but in a larger team, we might actually have programmers in France, and they could run into the same problem where it will pass by coincidence. So let's change it to be, instead of French, let's use Manx. That is GV-GB. Manx is a language spoken by the original inhabitants of the Isle of Man. It is not quite a dead language, but there are no primary speakers, and I think there's only 1,000 people who even speak it as a secondary language. So I think this is a pretty safe, inconvenient default. Very unlikely that we're going to have any code that actually wants Manx as its language. So by using this, we can, again, prevent that accidental success. So I'll come in here and I'll change this to use the Manx version. So now, if I were to run my code, even though it used to pass, now it's going to fail because it's going to assume Lord Howe as our time zone, and that is just not what we wanted. We wanted UTC. And so this prompts us to now specify the time zone. So that's another way to prevent your APIs from being used incorrectly, is to provide inconvenient defaults. Now, a third way is to not provide defaults at all, to actually require that everything be explicitly specified. Right now, this code, in addition to being incorrect, it's not obvious why it's incorrect. there's no clear indication of why the time zone is working the way it is. And if I wanted this to use the local time, the only way you specify that is by not providing it. It wouldn't be clear to a reader of this code why we wanted this to use local time. What we can do instead is we can explicitly specify when we want local time. If we go up here into our tests, one of our tests right here says that we output the current time using the computer's language and time zone. We can change this to say that the time zone has to be local when we want the local time zone. Now this, of course, is going to fail because local is not a valid time zone. So I'm going to have to come into our production code. And right here in toFormatted string, I'm going to have to say that if the international date time format options time zone is equal to local, then we'll set it to be undefined. And also in our test, we're going to have to say that this is the format that we're going to use, but the format that JavaScript is going to expect us to use is actually just this part. And I have to do this again because of the way the comparisons work when we're dealing with dates. And check out the last episode for that. Okay, so here we'll say JS format. And there we go. Now we can specify local for the time zone to actually say that we want the local time zone. And however, there is a little bug here. As always, we're modifying an object, and that's going to modify the caller's versions of the object as well. So let's say that we don't want that to be modified. So we'll say that the format still equals the copy, and it should not modify original format object. And this is going to fail because we're deleting or setting the time zone to undefined. That's not what we want. Instead, what we want to do is make a copy. And then we'll delete that copy, or we'll take the time zone out of the copy. In fact, let's delete rather than setting to undefined. And then here, we'll pass the options through. And we can do the same thing with our locale. We can say that if you want the local locale, you should explicitly specify it. So we'll say that the locale here should be local. That will be our production locale, and the JS version will be undefined. And again, the reason we're doing this is because we have to actually compare, because we don't know what time it is when we're dealing with times, we have to compare what's coming out of the production code versus what we expect to come out of JavaScript. Okay, that's still passing tests, and it turns out that when you use a locale that that JavaScript doesn't recognize, it defaults to the local locale, which is just unavoidable. But I am still going to say that if optional locale is equal to local, then we'll set it to undefined, just for safety. So that's option 3 for making your code less likely to be used incorrectly. Now this doesn't stop us from using the code incorrectly, but it does make it that if somebody is intentionally wanting the local time zone and locale, they can specify it. It will make it easier for somebody modifying that code in the future to understand what's going on. In order to make it more clear how to use this code, though, we can use the 4th option I was talking about, and that's failing fast. Using our failing fast in our code and using that to document how it should be behaved. When you write your code to fail fast, what you do is you check to, as soon as possible in your code, you check to see if it's being used incorrectly, and you throw an exception so that the programmer can learn that it's being used incorrectly right away. In our case, we're using the code incorrectly because we're not passing in the time zone. What we can do is we can write the code to fail fast by checking that if the time zone isn't set, throwing an exception. And I'll show you what I mean by that. We're going to say that it fails fast if time zone isn't specified. So write some code that's going to create a clock and then call toFormatted_string, and it's going to have format options with no time zone, and we'll pass in a valid locale. And at that point, we should expect an exception. And what we want to do here with this exception, we don't just want the code to fail. We want it to fail in a way that documents how the code should be used. So we can say that it must specify options.timezone, and we can say use local to use for computers' local time zone, or just computer's time zone. That way, when somebody uses this, they're going to come along and they're going to see that it uses the international date time format options. If they forget to put in the time zone or they don't want the time zone, when they do that, the computer will tell them, no, this is how it's supposed to be used. Programming this, of course, is going to be really straightforward. We're expecting an error, but we're not getting one, so we'll just say that international date time format options, if the time zone is undefined, we'll throw a new error with our message. That is going to cause some of our other tests to break, because we do have additional tests that deal with having a local time zone. Right here, these two tests both do that. So we'll just specify time zone of local. And a time zone of local. And there we go. We can do something similar with the locale. We'll say that the locale cannot be optional, that we want it to be required. And we'll have it fail fast if the locale isn't specified. So this time we'll give it a valid time zone, but we'll leave out the locale, and we'll get the same sort of thing. We must specify locale, use local for computers, default locale. So Charlie Pancake asks, how would you make the local option discovered to callers? Well, exactly the way we're seeing it here, Charlie, by failing fast if they don't provide it. Now, it is true that there's no way to really know that that locale is out there without reading the documentation, which, like we said, nobody's going to do. But by saying that it is the international date time format options, it's possible that they're going to either know how the international date time format options works, or they're going to go read that documentation. And when they do, they'll discover that undefined is how you say locale. And when they try that, then of course they'll get the error. That's the best I've got here. I can't think of another way to make it discoverable other than that. Oops. So that is passing, but now we've got our null test failing again. So we'll just come down here and fix these. We will pass in the local time zone here, or the local locale here, and the local locale here. And there we have it. That is 4 options for making idiot-proof APIs. Let's see how this works in practice. So let's go back to our example. We're going to comment all this out. Somebody's coming along. They're a programmer. They know that they're supposed to use the clock module, but they don't know how it works. So what are they going to do? Well, they're going to say clock dot. They're going to find toFormatted_string. And they're going to see this time that it says International Date Time Format Options. Okay, let's go figure out those options. We'll figure that out. We put in the options, and we run it, and we see what happens. And that did not fail because it's commented out. Let's go ahead and try that. Now this time, it tells us we must specify the options.time zone, or we can use local for computers time zone. This is using the fail fast code to tell us how to use the code correctly. And I really love this message. I think it does a great job of explaining how the code should be used. So here we know that we don't want to use the local time zone, so we'll specify time zone UTC. And now it's going to fail saying we have to specify the locale. So again, we'll put in EN-US. Now our tests pass, and when the code actually ships, it's going to work properly for real this time. So that is, again, our 4 techniques for making idiot-proof APIs. Clarify the usage with names. So people aren't going to read the documentations. Use your names to provide hints about how the code should be used. In our case, rather than just saying format, we said International Date Time Format Options. Provide inconvenient defaults so that the code doesn't work correctly by coincidence. In our case, rather than making UTC the default test time zone, we used Lord Howe Island because there's very few people in our programming team who are going to be on Lord Howe Island, I think. Sorry to all of you Australians on Lord Howe Island if I'm wrong about that. Or is it Australian? I think so. I don't know. Sorry. Third, require explicit code instead of defaults. Rather than having the code assume that we wanted the local time zone and local locale when they weren't provided, we have to put in local specifically to say we want the local time zone and locale. And then we documented that by failing fast when they were not specified. And we actually wrote right there in the air, use local to mean local time zone. Now, I'll be honest, I don't always write my code to fail fast so explicitly. It depends on how much my code is being used by others. If it's just a tightly knit team where everybody understands what's going on, I'm going to put a lot less effort into my fail fast code. But if I'm writing a public API that I expect other people to have to learn how to use, then I'm going to be really explicit about how that works. Now, I see that there's been some comments in the chat. I'd be happy to take additional comments and questions about this topic in a few moments. Before that, a couple of announcements. First off, next week's episode is going to be on testing infrastructure that performs a lot of output. Specifically, what we're going to be doing is writing a logger. And one of the interesting things about that is that logger is going to be using a lot of the other infrastructure that we've written. So it's also, in addition to being about testing infrastructure that writes a lot of output, it's also going to be about writing infrastructure that depends on other infrastructure. So check that out. That's going to be Tuesday, August 4th. And then again, if you liked what you saw today, I would love to hear from you. jshore@jamesshore.com is the way to contact me. Happy to set up a private cohort just for you and your team. Of course, I can do that remote. I've got this neat flipped classroom technique that I can use with you. And it's always in your language, using your libraries, often involving your actual code base. So again, if you'd like to try that out, give me an email, jshore@jamesshore.com. All right, let's look at the questions and comments here. So we were talking about, Charlie Pancakes was saying, how do we make the local option discoverable to callers? And Charlie Pancakes suggests using 2 locally formatted string. I think that's an interesting idea, Charlie Pancakes, and I'm definitely not opposed to it. Uncle Scientist says you don't want to have a million methods, though, which I would also agree with. I would say that if I had just the local time zone or just the local locale, I might do that. But in this case, we've got 4 options. We'd have to have 2 formatted string, and then we'd have 2 formatted string with local locale, 2 formatted string with local time zone, and 2 formatted string with local time zone and locale. That gets a little bit messy. That said, one of the refactoring options in Martin Fowler's refactoring book is, rather than using a flag, use named methods. And I think there is a lot of value to doing that. I will often use just 2 different named methods rather than a Boolean, for example. And Charlie Pancakes goes on to say that they would let usage dictate further changes to the API. And I think I agree with that as well. Okay, I don't see any additional comments, so today is going to be a short and sweet episode. Again, 4 options for making your code less error-prone, easier to use correctly, and actually self-documenting by having it literally tell you what to do when you use it incorrectly. Again, next week's episode is going to be about testing infrastructure that performs a lot of output. That's going to be Tuesday, August 4th at noon Pacific. Hope to see you there. For today, that's all I got. So thanks very much for watching, and I will see you all next time.